So now we will presenting our assignment, which is wavelength decision multiplexing and its role in 5G or 6G networks. So our group member will be Tan Kang Ling and me, Jake Kanjinje. Next will be Muhammad Zul Husni bin Muhammad Saleh and Muhammad Firdaus bin Nasaruddin. Now I will presenting introduction for the role of WDM in 5G and 6G network. So mobile communication is growing rapidly due to the widespread use for smartphones and smart devices. At the same time, many users access the network simultaneously, which creates heavy traffic. So the applications such as online media streaming, online gaming, smart homes, smart cities, and IoT require very high internet speed with low latency. While 5G already supports these services, 6G network will require even higher speed and better performance. So the wireless links alone cannot handle this massive data traffic efficiently. So therefore, fiber optic infrastructure is needed to connect base stations and core networks. The WDM plays an important role by allowing multiple data signals to be transmitted on a single optical fiber using different wavelengths. So this significantly increases capacity without installing the new fibers lah. Then in 5G, WDM supports front haul, mid haul, and back haul connections, and in 6G will be critical to meet extreme bandwidth demands. So next will be the literature review. The early optical fiber systems were limited to transmitting only a single signal per fiber, which restricted capacity. The WDM was introduced to overcome this limitation by allowing multiple signals to travel in the same fiber using different wavelengths. So dense WDM or DWDM uses closely spaced wavelengths and provides very high bandwidth over long distance transmission. In 5G networks, technologies such as massive MIMO and small cells generate large amount of data traffic. So WDM-based Frauhorn support high-speed and low-latency communication to handle this demand. With the introduction of cloud radio access networks, which is CRAN, the need of high-capacity fiber links has further increased. So for future 6G system, WDM is proposed to support ultra-high speed and ultra-low latency services. However, challenges such as higher power consumption and complex wavelength management still exist. So for the system component background, first is the optical transmitter. It starts to communication process by converting electrical data into optical signal. A laser with a specific wavelength is used, and stable wavelength control is essential for WDM operation. Next is the WDM multiplexer. It combines multiple optical signals, each with a unique wavelength, into a single optical fiber. This helps avoid interference between signals and increases transmission capacity. Thus, the optical fiber carries the combined signals over long distances. Compared to copper cables, optical fiber has a very long signal loss and is immune to electromagnetic interference. The single-mode fiber is commonly used in WDM because it supports high bandwidth and long transmission distance, making it ideal for 5G and 6G networks.
Hi, my name is Muhammad Firdaus bin Nasaruddin, and right now I will continue on the slide of system component background. So the next one, we got the optical amplifier. which boosts signal power during transmission and also amplifies light directly, and no electrical conversion yet. And well, it can reduces delay and system complexity, and also ETFA amplifies multiple wavelengths at once, and it also suitable for WDM systems. The next one is WDM demultiplexer, which separates combined signals at the receiver side, and it splits wavelengths into individual channels, and also it operates as the reverse of the multiplexer, hence the name demultiplexer, and also it ensures accurate wavelength separation. Last but not least is the optical receiver, which it converts optical signals back into electrical signals, and it uses photodetectors, and the electrical signals are then processed by the network equipment, and it requires high sensitivity for high-speed data recovery. From this point forward, I will explain a bit about the application insight in regarding role of WDM in 5G and also 6G networks. So now I will continue on presenting about the capacity enhancement in optical fiber networks. So firstly, WDM increases fiber capacity by allowing multiple wavelengths to carry data on a single optical fiber. Instead of using separate fibers for each signal, many data channels can be transmitted simultaneously on the same fiber. And one major advantage of WDM is that no new fiber is required, and this significantly reduces installation and also maintenance costs while maximizing the use of existing fiber infrastructure that has already been deployed. And because of these benefits, WDM plays a critical role in backbone networks, metro networks, and submarine cable systems, where high capacity and long distance transmission are required. And WDM also supports the rapidly growing traffic demand from cloud computing, video streaming, and also mobile communications, including 5G and future 6G networks. In summary, the key advantage of WDM is its ability to expand network capacity at a low cost, making it essential for modern and future communication systems. So in this section, I will discuss more about the role of wavelength division multiplexing, or WDM, in 5G and future 6G networks, with a focus on front-haul and backhaul applications. So 5G networks require high-speed and low-latency connections between base stations and the core network, and these connections are known as front-haul and backhaul links, and they carry extremely large volumes of data in modern 5G systems. With the deployment of dense small cells, data traffic increases significantly, and this creates a strong demand for high and efficient capacity transmission solutions. And WDM addresses this challenge by enabling multi-gigabit optical transmission over a single fiber. And multiple 5G radio frequency signals and services can be transmitted simultaneously using different optical wavelengths without interference. And by using WDM, network can maintain a low latency and accurate synchronization, which are critical requirements for 5G performance. And this technology also supports centralized and cloud-based radio access networks, such as the C-RAN, by providing reliable and scalable optical transport. And in summary, WDM offers an efficient, scalable, and also cost-effective solution for optical transport in 5G networks, and it will continue to play an important role as networks evolve toward 6G.
Hi, my name is Zulhusni, and I will continue about the application insight, which is enabling ultra-low latency and reliability. 5G and future 6G service require ultra-low latency and high reliability. The example is include autonomous vehicle, remote surgery, industrial automation. Basically, WDM allows dedicated wavelength for critical service, which is it can reduce network congestion and channel interference. It also help minimize latency for time-critical data, improve network reliability and resilience. Other than that, it also enables mission-critical communication services and high reliability and low latency support for advanced 5G and 6G application. Next is the last part of application insight, which is foundation for future 6G and intelligence optical networks. WDM is key to smart adaptive optical networks for 5G and 6G, which is it support high-speed service like extended reality, holographic communication, and it also advanced implementation included dense WDM, DWDM, software-defined networking (SDN), AI-based network management. In AI-based network management, it enables real-time traffic handling and dynamic mapping assignment. It's also flexible, energy efficient, and future-proof for evolution from 5G to 6G. It has high speed, adaptive, and intelligent optical network for next-gen communication as in the figure below.
Now I would like to talk about the safety, health, legal, and also the cultural consideration. For safety and health issue, WDM network uses optical fiber that carry infrared laser light which cannot be seen by the human eyes. Lookingly directly into an active fiber or laser source can cause serious and permanent eye damage. The risk is higher in dense WDM system because multiple high-power laser signals are transmitted at the same time. To keep safe when working with fiber optic, technicians must wear laser safety goggles, keep the fiber ends covered when not in use, and also use the optical power meter instead of direct viewing. Warning signs should be placed in equipment room and work area, and proper safety training must be provided to all technicians. So next is about the legal and regulatory issue. WDM network must follow international standards such as ITU-T and IEE. These standards ensure compatibility and reliable operation across the different countries. They are especially important for 5G network and also future 6G system. Data protection laws must also be followed to prevent the data leakage, hacking, and unauthorized access. Fiber installation must comply with local regulation including installation approval, workplace safety rules, and also the environmental guidelines. Failure to comply with these requirements may result in fines or legal actions. For the cultural and social impact, WDM enables high-speed and reliable communication. It helps to improve the access to education, healthcare, and government service. It also helps to expand the internet connectivity in rural areas. WDM support remote work, online learning, and also the long-distance communication. It reduces the needs for travel and helps overcome geographical barriers. It also promotes culture sharing through video calls and also the social medias. So WDM plays a key role in the development for future 6G networks. In conclusion, WDM allows multiple signals to travel in one optical fiber by using different wavelengths. This increases fiber capacity without installing new cables and help reduce network deployment costs. WDM is used in 5G front-haul, mid-haul, and backhaul network. It provides high data rates, low density, and reliable communication link. WDM support many applications such as video streaming, smart city, and the Internet of Things. So that's all from me. Thank you.